Now this is a problem that can drive students crazy. We're given this function y equals 2x plus 1 to the 10th times 3x plus 1 to the 7th. And the problem requests that we simplify it to look a particular way. Now one time I had a class of students that were upset that they didn't have answers on an exam, and oh, if we just had the answer we would do better. So I gave them an exam that had all the answers on it, and then when the test was over they asked me to not do that again. Because this is a very hard kind of problem. You know, you're working on the problem and you think you have it right, but yet you can't manipulate it to look like what the answer is. So this requires a lot of skills to take a look at what you have and take a look at where you want to go and try to put the pieces together. So I'm going to start by taking the derivative of my function here, and I'm going to use the power rule because that's the big one. This function times this function. And the power rule says that I have to take the derivative. I'm going to use this notation here. The derivative of the first guy times the second guy plus the first guy, I guess I should say function, times the derivative of the second function. That's the product rule. Whoops. So now I can take the smaller derivatives. I'm going to use the chain rule here. So derivative of the outside, I bring down the 10. I subtract 1 from the power, and the inside remains the same. Then I have to multiply times the derivative of the inside, which is 2. And then I have to bring the 3x minus 1 to the 7th down. 2x plus 1 to the 10th, and the next term comes along. Derivative of this guy again requires a chain rule. I bring down the 7, subtract 1 from the power, the inside stays the same, then I multiply times the derivative of the inside. Now, I mean, you can simplify a little bit. There's not a whole lot to do. Please don't multiply everything out. Anything that has a power that's bigger than 2, don't multiply it out. So 10 times 2 is 20. And I'm just going to set these two other terms, or I'm sorry, factors here, just set them right next to each other. And then over here I'm going to multiply the constants, 21. I notice that 20 and 21 don't have any common factors. So 2x plus 1 to the 10th and 3x minus 1 to the 7th, or sorry, the 6th, just stay sitting next to one another. Now here's the kicker. I look at this and I look at this. And notice this is 3 factors multiplied together. And this is 2 terms. Now the last thing that I'm going to do is multiply everything out, because all that does is it creates 100 different terms. Terms to the 9th power, terms to the 8th power, terms to the 7th power, terms to the 6th power. That's a lot of terms that doesn't look anything like this. But I do notice that there's a 2x plus 1 to the 9th and a 3x minus 1 to the 6th sitting there. And I notice that that's a common factor here. And it's also a common factor here. So maybe factoring out common factors would be the right idea. All right, so let me go down here. We'll have to check up and down for a little while. So I'm going to factor out a 2x plus 1 to the 9th out of both terms. I'll do that first. So what's left? When I take this out of this term, I'm just left with 1. So 20 times 1 times 3x minus 1 to the 7th. When I take them out of this, I have a 2x plus 1 left. 21 stays the same. I have 1, 2x plus 1. And then the 3x minus 1 comes along. To the 6th, of course. Now, if you're disturbed about this, all you have to do is look at this and say, okay, what if I multiplied this term by this term? It looks like that. If I multiply this times this, it looks like that. I always think of pluses and minuses as separators when I'm dealing with factoring out things. Now I'm going to factor out 3x minus 1 to the 6th out of both. So 2x plus 1 to the 9th. 3x minus 1 to the 6th. Now in the first term, if I take that out, I'm left with the 20 times 1 comes along. Then I'm left with just 1, 3x minus 1. And then the 21 comes along, and I'm left with 2x plus 1. And then factoring all those out, I'm left with times 1 there. If we compare this to what we want, you can see we have 2x plus 1 to the 9th, 3x minus 1 to the 6th. And if we come back up here, you see 2x plus 1 to the 9th, 3x plus 1 to the 6th. Now we hope that the stuff that's left in the parentheses turns out to be 102x plus 1. Now I'm going to come down here and I'm going to write down off to the side 102x plus 1, so we remember what we're looking for since we can't see it. Alright, so now I just have to do the algebra in here. It's very straightforward now. 2x plus 1 to the 9th, 3x minus 1 to the 6th, that just comes along. Now 20 times 3x is 60x minus 20. 21 times 2 is 42x plus 21. And again, don't be a lazy mathematician. Write everything down. This is not a game of who can show the fewest steps and who can make the most mistakes. So I'm just rewriting this first part again. Now I know 60 plus 42 is 102. That's exciting. And minus 20 plus 21 is plus 1. So it looks like we got the right factor there, and we've finished.